So we'll be taking two courses. One is this CS 21002, that's switching circuits and logic design, and the other is CS 29002, that is the switching circuits laboratory. Okay, so 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 the conduction of this course, I mean, so have you opened this WBCM page, all of you?
Yes, sir.
Okay, so you can just click on go here. Okay, just so it should indicate 2021 spring. This is the run of this course, CS 21002. If you click on go, you get this opening screen. So I've put some information. So you just look at this information from the bottom of the page. So first of all, I have put down the course syllabus there, which is of course just a copy of the approved syllabus. Okay, just a copy of the approved syllabus, and then there are some suggested books and references. So this one is a very good book. I mean, this is the book that we prefer. That is the book by Kohavi.
CRM, can you
Yes.
increase the font size a little bit?
Oh,
Maybe
sure.
not.
Yeah.
Maybe I have classes. Maybe others have also.
This is a bit small because you don't get the full thing there either. So I think it should, oh, sorry.
Maybe Control Plus would do. Control Plus.
Is it readable now? Is it readable?
Just once more. Yeah, this is fine.
Okay. Yeah. So this is the preferred book by Kohavi. Well, the original author is Kohavi, but later on, Neeraj Jha has also joined in, and he has also put in some extra topics. So this is really the best book, but we have put in hello, others, please mute yourself because we are getting some, please mute yourself.
CRM, can you turn off your video? Maybe because of the video, it's taking more bandwidth. Please turn off your video, maybe.
Oh, is it not turned off? Okay, I'll just, 1 second. I'll just turn it off. Okay. Is it, okay, it is on. Yeah. So, so this is the preferred book. I think a soft copy of this is also available on the net. I think so. Yeah. So maybe you can get hold of that as well. Other books are also there, but this will be the main book. Now, of course, you have the class schedule, but I've put that here as well. And I've put some links here, so possibly you could just click on these links to join. At least I was able to join by clicking on this link. So I hope you too will be able to join by clicking on these links on these various days. Here are some, course outcomes. So, of course, when you do this course, what do you expect? What kind of proficiency do you expect at the end of the course? So I've just listed some, outcomes to the best of my understanding. So this is, of course, I've tried to keep it compatible with the items in a syllabus. So one aspect is, understanding the algebraic basis of Boolean logic, and then we'll look at representation of information in Boolean form, and including number systems. So of course, many of the some of these things you will actually be knowing, because in the course on programming and data structures, you have already studied the binary representation of integers and floating point numbers. You have also, I think, looked at the 2's complement representation. So we'll look at a few more aspects over here. Uh, One of the things that we'll be looking at is when you send data, say you are sending data from your PC to your printer via some cable, it is possible that due to electrical noise, one of the bits gets flipped. So, is it possible to identify such a situation? Is it possible to correct such problems? So these are some very practical problems that are faced in digital design or design of systems. So we'll be looking at those aspects as well. Of course, uh, optimization is a common theme. So we'll be looking at three types of circuits, that is combinational circuits, synchronous sequential circuits, and asynchronous sequential circuits. Uh, we'll not get into the details or the difference between this synchronous and asynchronous sequential circuits right now. Just know that these are three types of circuits we'll be looking at. Of course, first of all, we'll be looking at combinational circuits, and in all of these, for all of these, there is an aspect of optimization. So we'll be looking at optimizations, and we'll also be looking at hazards. Okay, so that's a pretty interesting area. I think we'll study hazards when we get there. And then, of course, we'll be looking at design of common digital building blocks such as counters, shift registers, barrel shifters, etc. So these are the outcomes that I could think of for this course. So make sure that we should be able to do all this as the course progresses. Now, this is an important aspect. This is the conduction of the course. Okay. So far as conduction of the course, of course, I've already told you that the course will be with the two teachers, and we have a number of TAs. So TAs will be playing an important role here, and they always play an important role. Many of the assignments will be, or rather the assignments by and large will be evaluated by the TAs. And we will of course try to ensure that the evaluation of assignments is uniform. Normally a single TA will evaluate a set of assignments. We'll also try to keep the load of assignments, we'll try to distribute the load of assignments. So this will, require you to constructively cooperate among yourselves. So the plan that I have thought of is, for the theory, we'll have a number of groups, student groups. In fact, you should form the student groups among yourselves. So we'll have, say, groups of 10, we'll have groups of 10, and we'll be giving, problem sets to you. So maybe each set will have about 10 problems, let us say. So what you'd expect is that each member of the group will take the responsibility of working out each problem, each distinct problem, and you should discuss among yourselves. It is not just that somehow you work out the problems and submit. So that is what I meant by constructive cooperation between yourselves. So while you can distribute the load, that is fine, but you should also discuss the solutions and the problems and the solutions among yourselves in the group, and make sure that if there is some mistake, you correct that mistake and also understand how each problem in the given as an assignment has been solved, and that will also help you because later on we'll have a test. So we'll also tell you, to identify the person who has taken the lead role for solving each problem, and at the end of the course we'll also have a viva. So we'll be asking you, we'll be focusing mainly on the problems which have been given to you as assignments. So since you would have, done these problems, through group effort, we would expect you to be able to answer, any of, or be able to solve any of these given assignments or a similar assignment during the viva. So that is how we intend to conduct the the course and give you assignments. So we will normally give you assignments after a topic has been completed. So here, so as you can see, we intend to give you sequence of assignments, but the overall load won't be too high because we don't expect everyone to solve each assignment. We rather expect everyone to solve one problem and you discuss the other problems among yourselves. And this will also help the TAs because they will, their load of evaluation will not be, too much to handle. So this is the scheme that we wish to follow. We are planning to follow during the semester. And we'll also conduct a series of tests. Each test will have just, maybe just 2 questions. So you might actually have. Now we have planned 4, but it could be more also. But we intend to keep each test, small, so that you just have to answer, a few questions. And again, those will be marked by various TAs. Now, in the present situation, the exams will be you'll have to take the exams at your place of residence. So we have formulated some guidelines. For proctoring. So now there are some, in a normal exam, you sit in the class and you answer. So, but over here, you'll be answering from home. So just to ensure that people don't raise questions about these exams, we have formulated a proctoring scheme. So here you'll be expected to record your performance in the exam. So you should be you should position your laptop so that your upper body is properly covered, so we can basically see what you're doing. However, it is not very practical to see or monitor everyone in real time because there may be the internet may be disrupted for some and so on. So the minimum that we have planned is as follows. So you should record your the entire session and save that. And what you should do is you should compute what you call a cryptographic hash, the MD5 hash. Okay, it's not that powerful, but we'll still go with MD5 hash, and that hash you are supposed to upload. So basically, the idea is that whatever you have recorded, you will preserve that carefully, so that we can review that as and when it is convenient. And you are expected to keep all your recordings safe, so that those can be examined at any time after your examination has been completed. So please maintain this guideline very carefully. Follow this guideline very carefully. So the relevant comments and all are given here, so that you don't have any problem. Sometimes the size of the recording may be a bit okay. Yeah. So the other aspect is that whatever you write, we expect you to answer. We expect you to answer on paper. So you should, of course, keep those answers safely, but you are expected to, send those answers. Take a if you have a scanner, you can scan the image, or if you don't have a scanner, you can take a picture on your mobile. You should take a high quality picture, but at the same time, uploading a very large file is problematic. So we would prefer you to compress that file. So the relevant command is given here. This is the command that you can use to compress your file. So we expect that you will compress your file before uploading it. I mean, that is important, because it is not just a problem of storage, because a large file doesn't come across very well over the network. So you might have problems submitting if your file is large. So you should definitely try to compress the file before you submit. So we have given you, commands for a single page PDF, for multi-page PDFs and all that. So these are to assist you. Hopefully, you will be able to come back towards the end of the semester. If that happens, then of course we'll have a regular NSEM. I mean, that's what I'm hoping. I don't know what will happen, but that's what I'm hoping. So if you're able to come back by the end of the semester, then instead of the FICO exam, we'll expect to conduct a regular NSEM. So we have to see what happens. So these are the basic instructions. Of course, over here we'll be posting the lecture material for your reference. So you will be able to, you'll have access to those. Now, note that over here you have, basically three items. One is main, one is students, one is staff. So presently we are in main. Okay. Now, when you take exams, or when you submit assignments, you should use the students menu. So over here, as you can see, you have some facilities here. Now, this attendance facility will not use from WBCM, because I expect that this MS Teams will have an internal attendance facility as you attend the lecture. So
yes. So what we'll do is that there is an attendance which you can automatically download.
Okay.
In MS Team. Huh.
Yeah. So we'll not be using the attendance facility of WBCM, but now when you try to basically so the most important part for you is basically the assignments. Now when you click on assignments, as you can see, you are prompted for a username and a password. Okay, so let us see where you can get your username and your password. So let us go back to main. If you look at the submission log, uh, I have populated this course with the names I could get from ERP. So it is possible that a few of you might have been left out. So please check this. If you have been left out, do get back to us and we'll include you. So this is this is these roll numbers and names have been added from the information that I got from ERP. Okay, so please check whether your name is there or not if you have registered for this course. Now, so your roll number as shown over here, as shown over here, this is case sensitive. So this is your user ID also, and your password, your default password is user ID followed by 12. So if your roll number is 17CS10034, then you just append 12 to that to get your default password. Now, once you have entered your default password, you'll be prompted to change your password. So you have to change your password and change it to something which is non-trivial. Let me tell you that you should keep your password confidential, because later on, if any issues come up, we would not like to say that XYZ got my password or guessed my password and all that. So make sure that you don't use a trivial password. Use a password that you can remember. I should also tell you that don't use too many fancy characters. So just use alphanumeric characters, underscore, because there are a few things which are not very well handled. So if you use those characters, your password might not work. So this is something. This is a known problem right now. So just be a bit careful. Don't use too many fancy characters in your password. Just use the, I think star, minus, etc. should work, but dollar, just be a bit careful. Okay, so this is about your, so right now, no assignments have been posted as yet. We'll be posting the assignments in course of time. So this is your introduction to how the course will be conducted. So would you have any questions? Any doubts or any questions on what has been said so far? Yes.
Sir,
Yeah.
in the according to our means when we checked the website, as you shown in the video, we didn't see that reference book column. It was
Sorry,
different in our
what did you not see?
reference
So
book
he is
column.
not seeing the list of books, except suggested books, and that is
in
not
the,
seen
in
in
the
the
web
web page.
page.
Maybe you can refresh your web page once.
No, okay. Let's go back. All of you just do it a bit carefully. First of all, open the basic WBCM page. Are you there?
Yes, sir. Means we are only seeing some columns of it. It's not like whatever all you showed is there in that.
No. Are you seeing the page which is shown now?
Yes, sir. In the video, I'm seeing it. Yes.
Yeah, but you should be able to open. This is very simple. csc.iitkgp.ac.in/WBCM. So first of all, are you getting this page?
Yes, sir. We followed these, and I went to the web course page.
Let us just see. So this one, I hope you are getting all the columns here. This is just a simple table, right?
Yes.
Okay. So now, are you getting the CS21002 2021 spring?
Yes, sir.
So if you click on go, you should get this screen. Are you getting this screen?
Yes, sir. Means conduction of lab. We are getting okay. Yes, sir.
Are you getting this screen?
Yes, sir. Yes, sir.
So
It's fine.
if you scroll down, I mean, everything that I've shown you is just on this frame itself.
Means it was my mistake. I've seen the laboratory one. Sorry.
Okay, so now it's okay, I hope.
Yes, sir.
Okay, good. Any other question?
So you mentioned that while submitting the assignments, we are like have to submit images of the paper that we are writing on.
Yeah, image of the paper, because how else will you submit? Okay, no, the reason is, I mean, we can also have a form, but the reason I've not gone in for a form is because,
No,
you know,
actually, I wanted to ask that would it be possible to submit a PDF that have been like written by a digital pen or something?
yeah, why not?
Means like paper is not compulsory, right? Matlab-
No, I mean, that is actually better, but everyone might not have that facility. So, yeah, if you have a facility to, for example, if you are using Xornal, so are you familiar with Xornal? In fact, these slides which are open in front of you, that's opened in Xornal. You can probably read at the top of the in the title bar XOURNAL. Can you see that? Hello.
Yes, sir.
The Xornal is a very convenient software. So with this you can use a stylus if you have one. If you don't have one, you can just type also. And the great thing is that this one has facility for LaTeX formula. So you can also write write formulas and have those displayed as formulas. So this one could be very convenient for you. Uh, I would suggest. I mean, if you answer in Xornal, your content will be neat. You will be able to use formulas, and your resulting file will also be very small because image files are larger. So yeah, I have no problem with that. You can use a stylus. You can use Xornal. You'll have this one generates a PDF as well.
See,
Okay.
how you do is not very important. What is important is that if the file is small, it's easy for you to submit. If it is neat, it is easy for us to read. And so we have only these two requirements. It should be small, it should be neat. Beyond that, whatever is convenient for you, you can do.
Yeah, that is really the gist of it. Okay, so
So the submissions will have to be made on WBCM, right?
yes.
Yes.
So if you open, I mean, right now you will not be able to see how to submit. That is because we haven't put up any assignments as yet. But when assignments are put up, you will get the appropriate links to submit. So once we have covered some topics, we will be giving you assignments. You will get to know how to submit as well. So yeah, so you didn't worry about that immediately. Okay. All right then. So I think we have had a basic introduction. So let us just start with the course. I will just start it. After that, Professor Mitra will take over. Then maybe I'll say something else. So let us this is just a toy example to motivate, I hope, you'll get some motivation from this example. So this is a, a simple requirement. Let us say that you have a room, maybe it has a window, so you can get some natural light from outside. But of course, it may get dark. It does get dark, so sometimes it could be cloudy, so you may not have enough light. So maybe you like to have a way to maintain adequate brightness in the room by turning on a light bulb. It is really as simple as that. That is the requirement. Except that you want it to be done automatically. So the basic requirement is simple. If it is dark in the room, you want a light bulb to come on so that you have some light. And of course, you don't want the light to be there if you don't need it. You don't want to waste electricity. So we have just taken this as a hypothetical example. Of course, after you have done the example, you might find other simpler solutions. But this is just to motivate you to see how we connect a simple practical requirement to a problem in digital logic. So of course you need to know whether there is adequate light in the room or not. So you can do that by you can sense the illumination level using a sensor, a light sensor, and that sensor, let us say that it gives you a Boolean output, okay? And let us call that output as X. So it simply tells you whether it is you have a low light situation or not. So let us say it is 1. Let us say the Boolean variable X takes on the value 1 if it is low light, 0 otherwise. So here of course we have assumed that you have what you call Boolean variables, which take on values either 0 or 1. Okay. So that is our assumption now. So note that there is some degree of abstraction because your light sensor as such doesn't give you a Boolean output. So if you really want to construct such a circuit, you will find that you do have to have some more components, like resistors, transistors, etc., so that you can use the the main sensor element to get a Boolean output. So what's a Boolean output? So abstractly we say that it is either 1 or 0, but in practical terms it has to be some physical quantity. Okay, so the physical quantity is usually a voltage. Okay, it's usually a voltage. Now what is the range of the voltage? So that range of the voltage, we'll just assume that it is between 0 and 5. But again, let me tell you that the reason I'm making this assumption is because the switches, the chips, the IC chips, that you have in the laboratory now works in that voltage range. But if you think of the voltages that are actually used in your, the present day IC chips, say the IC chips which are used in your computer or in your mobile, that's well below 5 volts. Okay, there are reasons for that. We will not go too much into the electronics, but just note that there is a reason for that. One basic reason is that it takes more time for the voltage to change between 0 and 5 than between 0 to some lower voltage, say something like 3.3 volts or even less. And of course, if you have a higher voltage, your energy dissipation would also be more. You might know that the power is, if say R is the resistance of your circuit, then the power dissipation is V squared by R. So, or the power is V squared by R. So, as you can see, the energy dissipation increases as the square of the voltage. So, there is, a good reason to go for low voltage circuits. But again, as I told you, we are going to make use of abstraction. We will not go too much into this sort of circuit details, but you should at least know it. Knowing it is one thing, and so just know that we are abstracting things out here. So your Boolean variable is for x, the Boolean variable x takes on the logical value. So when you do this abstraction, we say that it takes on the logical value. We don't talk about the actual voltage. Okay, so it takes the logical value 1 to indicate low light and 0 otherwise. Okay, so you are able to sense it. Now what do you do with that? So presumably you have electrically actuated switch which can be controlled again by some Boolean input. Now again I'm saying Boolean input. So implicitly we are going with the abstraction now, because in an actual switch again you'll have to supply a certain voltage, So, but we'll go with the abstraction. We'll say that you have the switch. Let us say that the corresponding line is U. Okay, you have another Boolean variable U which drives the line to turn the light on or off. Okay, and let us say that the value 1 on U will turn the light on and 0 will turn the light off. Okay, this is just a convention. So we would like the light to be off if sorry, we would like the light to be on if the light is low, right? If there is low light. So now just see, the assignment of x to U should do that, right? Because x is 1 if the light is low, that is the convention that we have chosen, and if you assign x to U, you should get the light on, right, if there is low light. So now let me pose a question to you. Do you think this is a good enough solution? Yeah.
It is not a good enough solution.
Why not? Then you should say why not.
Because it doesn't take in the consideration that if there is someone who requires that light.
No, we are just assuming that We are just assuming that this whole system is enabled if someone requires that light. Okay, just we make that assumption. If no one requires that light, then let us say that this whole system is off. So yeah, okay. I mean, what you said is relevant, but let us just make that simplified assumption that if the system is working, means someone actually requires that light. Let us just assume that for now. Okay. Suppose we go with that assumption, then what do you think of this solution?
We should make sure that sensor goes off when light is on.
Okay, that so you would expect that the sensor will go off, because it's a light sensor. So if the light is, if there is adequate light in the room, it is expected that the sensor will indicate that it isn't low light anymore, right? So yeah, so that is okay. So
Sir,
yeah.
sir, we should ensure that an adversary does not flip the Boolean input.
Yeah, that is in fact what I told you some time back, that you might, the adversary, what you have said is actually correct. In fact, that was mentioned some time back, you can have noise. You can have noise which can flip your input. So you can treat the noise as some kind of adversary, and we also it was also mentioned that you have error detection and error correction mechanisms, which we shall study later. So yeah, at least with respect to noise, we do have ways to handle the situation. You can treat the noise as some kind of adversary, so we can handle that situation. But for the time being, let us just keep it a little simple. Let us say that we do not have to handle noise. Okay.
Okay,
So
sir.
yeah. So let me pose the question once again. So is this a good enough solution, or would you see some problem with it?
So how does it like takes the input when to turn off the light?
Oh, this, yeah, it is because U is the signal. So as you can see, if U takes on the value 1, then the light is turned on, and if U takes on the value 0, then the light is turned off. That is what is written here, right?
Yeah, that is okay. But
Are we
like,
solution continuously?
Sorry?
Are we running this solution continuously?
Oh
If
yeah, absolutely,
so,
yeah.
then the light will keep on flipping between on and off if it's dark.
Yeah, that's a good observation. So the way we have done it is that, okay, I mean, when if it is low light, it will definitely turn off. But as someone pointed out a while back, that once the light is turned off, the sensor will indicate that it isn't low light anymore. So it will, immediately turn the light off, or in a short while it will turn the light off. So that's probably not the way you wanted it to work, right? So we need to somehow solve that problem. So one way to, yeah, so that's what we don't want, the light to go on and off, to oscillate. So suppose we have some other variable to show that the light is on. I mean, this is a slightly make-believe example. You might raise questions. So yeah, so I'm just saying that let us say that we have another. You could relate L to U, but I'm just saying that let us say that we have a separate Boolean variable L, which specifically indicates that the light is on. Okay, so So it is 1 if the light is on and 0 if the light is off. So let us just say that we have such a variable. So we can modify this expression a bit. So suppose we say that, we'll turn the light on either if it is low light, or if the light is already on, then let it stay on. Okay. So so now does it solve the problem of oscillation?
It won't be off.
Yeah, okay, that is true, but it does solve the problem of oscillation, right? I mean, as it stands now. But yeah, the next problem is that it never goes off. Okay. So let us just say that if you have another Boolean variable to indicate enough light outside, okay, so this variable presumably takes the value 1 when there is enough light outside and 0 otherwise, then we could modify the expression like this. So I mean, this is slightly concocted, but this is just to show you that how you can capture various conditions and try to identify or try to get or construct an expression that has a certain utility. In this particular case, the utility is to turn the light on or off. Okay, so the final expression, so does that make some sense? Okay, the situation is a bit concocted, let us just go with that, but it presumably solves the problems that we identified. So is that okay with you? Yes? Any reservations against this expression? Yeah, is it okay, or do you have something to say? Okay, then I'll assume that you have nothing more to say about this expression. So this is just it is just saying that if it is dark, you turn the light on, and if it is if there is what I'm saying is that if it isn't dark outside, then you can yeah you keep it on. Okay, so that way we can somehow use this you can operate a light bulb. Now another aspect is that we wrote this expression in one way, but that need not be the only way to write that expression. So you could probably write it in a different way. Okay, we have got two expressions for you. Now when you have two expressions, natural question that arises is, are these equivalent? Okay, so that is a computational problem. You have got two Boolean expressions and you want to know whether those expressions are equivalent. So how would you do that? Any suggestions? Yeah? Anyone? How could you do that? Would anyone like to volunteer a suggestion? How you could do that?
Sir, by comparing truth table.
Yeah, you could do that. So there are many ways to do that. It's not just only one way. So one way you could do it is, you could of course simplify the expressions. You could work on the expressions algebraically. That is one way of doing it. Another way of doing it is you could just compare the truth table. So in fact, that is what we have done. So both these expressions are functions of x, L and y. So we could, construct, we could, just a minute. F2 পড়ে হ্যাঁ আমার class 2 আচ্ছা so we have so you could construct the truth table, and what you find is that, well, if you just do it, they turn out to be identical. So that's one way of checking that these two expressions are equivalent. Now you can have many such expressions. So I mean, you can have, down below we have just shown how you some algebraic steps through which you can also show that the two are identical. But you can have, in fact, all of these expressions are identical. Now, depending on how you construct, depending on your thought process, you might come up with any one of these expressions. So there is an issue of finding an optimal expression. How do you come up with an expression that's easy to construct, that is cost less? So that's how we come to the issue of Boolean optimization. All right. I mean, I think we have come to the end of the class today, so I think we can kind of wind up here. So this does give you a reason to have some optimization technique, because you could come up with any one of these expressions. All of these are equivalent. So you want to be able to get a low cost expression. All right.
So just one announcement: we'll not have the lab today. From the next week, we'll start our lab.
Okay. Yeah.
So Monday 2 to 5 p.m. is the lab. But since we have not covered any theory yet, we are not having today's lab. We'll start the lab from next week.
Yeah. So I'd just like to add that we have a lab page, so similar to this. So just go through.
Maybe CRM. Maybe we can discuss that in the first lab class.
No, I'm just telling
okay. You can quickly say.
Just a small thing. I'm just telling them. So in that we have asked you to download some software. So what you can do is you can just follow the instructions there to install the software on your computer. That's all, because I think you are proficient enough to install software on your own. So that in the next class we can actually start with some simple experiments. Okay. So just try to do that. That is, you can say, your lab assignment for today. Just go through the lab page and download the software, so that you can you don't have to use the software correctly now. Just ensure that those are installed and those software can be run. Exactly how you should use the software, those we'll deal with in the next lab class. All right. Okay. So I think we can stop here today.
Sir?
Okay. Yeah.
Sir, actually I've applied for this course and the lab component through ERP, and I'm waiting for the approval.
Yeah. So Pavitra, do you want to?
We'll do that. See, the problem is that there are about 120 people who have applied for approval, and we have a large caste strength of the computer science students themselves. So we'll not be able to accept everybody. We'll form a policy, but it's not a very large number that we can accommodate. We'll form a policy depending on how many people have actually applied. Maybe by today night we'll communicate it. What is our decision? The thing is that there are 120 people who have applied, and we cannot accommodate so many people.
Just one small thing I had to ask also.
You just wait till tonight. We'll look at the applications, we'll form an policy, and then we'll communicate the policy to you by tonight.
Yes,
Oh,
sir. Sure.
Yes, sir. I just wanted to add that kindly be final semester people be given preference.
Yes, definitely we'll look into that. We'll look into that.
And the people who are taken in the course, we'll add them to WBCM, so you will be able to see your names in the submission log also by tomorrow morning. Okay.
By tomorrow we'll because see, the thing is that whatever is a policy, it's not a first come first serve policy. So we have to wait till a good number of people actually apply for it. After that, looking at that number and looking at the statistics, how many people from final year and all those, we'll form some policy, and by tonight we'll communicate to you. You should try to understand our limitations is that we cannot accommodate a very large class. It will defeat the purpose of the course. So you just wait, by tonight we will communicate you.
yes.
Fine, sir. Fine, sir. Sir, I just saw second year students. They had got approval, and since it is my only subject that is remaining.
It is initially it was in the best of CGPA. Okay,
But
so
sir,
definitely on the best of CGPA we have done, but we'll do consider your appeal that for final year. Maybe we'll have a separate criteria for final year, but please wait. Please let us look at the numbers. By tonight we'll tell you.
Fine.
So just one small thing I had to ask. So will the lab be live, like we have to sit for 3 hours, or will we get assignments we have to submit weekly?
You will get assignments. What we'll do is we'll just discuss the assignment, which will not take very long. So we'll just discuss the assignment, we'll explain what it is about, and then you'll have to carry on with your work. So
Okay,
yeah,
so thank you.
we won't be interacting with you for the full 3 hours.
Also, one more thing we'll be doing is that we'll record both the theory and the lab class and put up in YouTube. So you can also refer to that later in YouTube.
Oh, by the way, I think can all of you record? I mean, on your own, just as we can record here.
No, they need not record CRM. So what we are doing is that MS team, a single team provides a recording immediately after the class. All you need to do is to upload it to YouTube and provide them the link.
Okay, we'll see where you can upload that, but it stays in the.
Stays for 15 days.
Yeah,
it
stays here itself. It stays here for 15 or 20 days. So even if you miss within 15 days, if you download from here on your computer, I think that will also be fine. Yeah. Okay. So I think we can stop now. Okay.
Yes. Thank you, everybody.
Yeah. Thank you. Yeah. Okay. We'll stop now.
So are you there now?